Hello everybody, welcome to our second night of notes on domain and range in the real world. Let's get right into our warm-up question. It says determine if each relation is a function and then determine the domain and range. So here we have a graph of the height of a sunflower as a function of time, which means that this is going to be my input. Time is always my input, and the height of the sunflower is the resulting information. Again, if you have this arrow, please turn that into a solid dot. If your workbook already had that as a solid dot, you are all set. We only have data up to a certain point. We shouldn't have an arrow there. All right, so looking at this graph, we see that at first, when it's first planted, it's really not that tall. This is in centimeters. And then over time, it's growing, it's growing, it's growing, and then it does reach a maximum height. Now, if our graph kept going, if we had data past this day, we would expect the graph to eventually come like this, because over time, if you see how the sunflower is kind of drooping over, sunflowers kind of fall over as they get older. And so maybe it hits the ground, maybe it stays like this before it dies, and it maybe only gets that high, or if it fell all the way to the ground, it would actually hit the ground. But we don't have data that goes out that far. We only have data up until this day. Last night, the focus was on really having this understanding that domain is no longer just about X, and range is no longer just about Y. These now have a meaning. So even though it doesn't say define the variables, we are, because that's really going to help us out. So to define X, let's say I hadn't already done this with you, the x-axis, I can pull it straight from the x-axis. X is number of days. And my y values, when I look at the y-axis, is the height of the sunflower. Height of sunflower. And that's being measured in centimeters. So now I know that my domain, which is all about x, well, x is days, so my domain is all about the number of days. And my range, my y values, is all about the height. And I'm just going to say height in centimeters because I don't want it to go out so far. But we understand that this is the height of the sunflower. Now I'm ready to use my pencil to help me get my domain. So for domain, we know that we're going to come in from the left, and then we're going to come in from the right. So when I come in from the left, I stop when I hit the graph, and I am at 0 on the x-axis. Now I'm going to come in from the right, and I stop when I hit that solid dot. And now we have to kind of do some reasoning on what's going on here. So if I look at the scale of this graph, I see that this is 20, and I see a little tick mark right there. So that's 10, 20, 30, 40, 50. So this is counted by 10, 60, 70, 80, 90, and a little bit. So if you put 90, I'd be okay with that, because people this year, your dot maybe is here or here. And when we adjust this to actually have the dot for upcoming workbooks, it will be actually a little bit past 90. So I would take 90 or a number like 91, 92, definitely not 100, because 100 so here's 80, here's 90, 100 would be out here. So give me an answer, identify a value close to 90 or 90, and we would be in good shape. Put my pencil to the side for a second. You're still using yours. So for set notation, let's get the setup. Curly Q bracket, that's kind of an ugly curly Q. Let me fix it. Curly bracket x such that, remember that's what that bar means, leave a space. The middle never changes. And now I'm going to put in 0 and 90. Day 0 is a solid dot, and day 90 is a solid dot, so they both get lines underneath. So this represents looking at data from day 0 to day 90. That's what this notation represents, because our x values, all of our possible x values is all about time, the number of days. So if you think about it, 90 days, that's a long time for that sunflower to live, but look how tall it got. It also looks like it's kind of reaching a maximum height here as well. If you notice, it kind of flattens out. So let's actually talk about the height. Our height is what our y value is all about. So let's turn our pencil sideways. And we're going to come in from the bottom. Now when I come in from the bottom, I see that I'm really not at 0. Because if it was at 0, it would actually start from 0. This is a little more than 0. Then I see that this is 50. So if I try to reason out what that is, mentally, I kind of think that's like 10. Because I could go 10, 20, 30, 40. I know my marker's kind of chunky, but if you fit in counting by tens, that would be roughly an even count of dashes. So I'm going to say 10. If you put anything other than 0, I would be fine with that. Like if you put 8 or 11, 12, 13, that's fine. As long as you're showing me that you realize that that is not actually starting at 0, I'm happy with that. So what that means is that at the day 0, when it was planted, it wasn't actually a seed. It was like a baby sunflower, maybe with a couple leaves on it. Those are leaves. It was 10 centimeters tall on day 0. That's what this means for this to be 10. Now when I come in from the top, I'm going to stop when I hit the graph, right there. I think when I scan this in, it's a little crooked, because if on your paper, if your flat edge, if you trace this across, I hit 250. So that's going to be 10 to 250. Getting our setup for the range, y between two values. So get the middle, close it up, 10 and 250. Both are going to get lines underneath. So on day 0, when it was planted, it was 10 centimeters tall, and by day 90, it was 250 centimeters tall. So this represents these are the corresponding heights for these days. So between day 0 and day 90, the sunflower had a height between 10 centimeters and 250 centimeters. Is this a function? Yes. Passes the vertical line test. And now we have a follow-up question. What's the maximum height of the sunflower? Well, height is all about the range. My largest y value is the answer to that question. 250 centimeters. So that's what really is important. We understand the real-world meaning of domain and range. The best suggestion I can make to you is that you put the correct label above domain and the correct label above range, and you'll always know what these values mean in the real-world question. Number 2 and 3, I will leave for you to do, and at the start of class tomorrow, you will compare answers with a partner. So after this video is over, please remember, and I'll remind you, but go back and work on numbers 2 and 3 for the warm-up, and tomorrow after our bell ringer, you will compare answers for these two. let's get into our first real-world scenario for the notes. In March of 1999, Bertrand Piccard and Brian Jones attempted to become the first people to fly around the world in a balloon. And these are them. This is a true story. These guys are Bertrand and Brian. I'm not actually sure which is which, but this is them. Based on an average speed of 97.8 kilometers per hour, the distance d in kilometers. I see that that is the definition of one of my variables, so I'm going to underline it while I read. That they traveled can be modeled by d equals 97.8 t. As soon as I see that I'm given a model, I'm going to highlight it because I want that to stand out to me. So if you're given an equation, highlight it. Where t is the time. Ooh, check it out. Another variable is given to me. That's nice, so I'm going to underline it. T is the time in hours. They traveled a total of about 478 hours. The rule governing the record states, that should have an S, states that the minimum distance covered must be at least 26,700 kilometers. All right, let's get into our questions. So I have a lot of information in here, but I'm just going to pay attention to what I need to define my variables. Let's start from the top. So because I did a good job of underlining while I read, right away I know that t is time in hours. T is time in hours, and d is distance in kilometers. And km is the abbreviation for kilometers. Determine the domain and range. As soon as I see that I have this, before I do anything else, I'm going to label. So domain, yes, domain is about x, but what does x represent? Well, time in hours. I know we're using t and d, but time is always my input, and then the other variable is always my output. So in this case, the output is the distance. So x is time. So I'm going to put number of hours because that's how we're measuring time. And then, yes, range is y, but now that actually has a meaning. My kilometers, my distance. In these situations, in these real-world questions, if you're asked for domain and range, you will be given a restriction. So go find the restriction. Somewhere in restriction. And what I mean by that is go read, come back up here, and either find something that restricts or limits the hours or the kilometers. So when I reread, this was just about who they were, how fast they were traveling, the model, and then look what it says right here. They traveled a total of about 478 hours. Is that a restriction on hours or kilometers? And I'm really not trying to ask a silly question. You have to ask yourself, is this a restriction on my domain or my range? Well, I might not be sure, but because we did a good job of labeling here, right away I know that, hey look, hours, hours. This is a restriction on the domain. So let's get the setup for domain x such that, put the bar right there, leave a space, and then the middle. They traveled a total of this many hours. So that's the max. That's the most hours they traveled. So it's going to go over here. I don't see a smallest number of hours. So just like we talked about in last night's video, the real world has a restriction on time. We cannot have negative time. So the real world minimum, the smallest number of hours, is going to be 0. 0 hours does exist before they started the journey, like before their balloon took off. That was the 0 hour. And then their 478th hour is their max. That existed also. So that's going to get a line underneath. So you could either use set notation or interval notation, your choice. And that's it, we have our domain. So this was given to us by the real world situation. We did not do any math. To find the range, so let me be clear on this. I'm going to actually write a note. To find the range, plug in the x values from the domain into, well, in this case, the model is D equals 97.8 T. So to find the range, we're going to plug in these x values from the domain into the model we were given. This is my smallest x. This is my largest x. So let's plug in the smallest one first. I'm going to do D of 0, using my function notation to keep track that I'm plugging in 0. So that's going to be 97.8 times 0. Well, that was easy because that's 0. And then I'm going to plug in my largest. Then I'm going to plug in my largest x value, so D of 478. That's going to be 97.8 times 478. Please press pause if you don't have your calculator out yet, so that way you can go get your calculator and do this. I'm going to take out my calculator while you take out your calculator. So 97.8 times 478 is 46,748.4. So we just successfully calculated the values for the range. Let's get our setup. Our range is between 0 and 46,748.4. I kind of had to erase my setup a little bit to make room for this big number. Both of these get lines underneath because this represents 0 kilometers, which exists. They haven't gone anywhere yet, and 46,748.4 kilometers. Meaning, over the course of their trip, they traveled between 0 and 46,748 kilometers on their journey. Giving you a second to really look at that and think about what you just did. So we had the smallest and largest x values. That came from reading for information. We were told they traveled a total of 478 hours. To find the range, we plugged in those x values from our domain to find my smallest y value and my largest y value. And then I was able to set up my range. You could also use interval notation, so that would be 0, 46,748.4. Either is good. Did they travel far enough in the 478 hours to set the record? Well, to be able to answer that question, we must have been told something about the record. So when I look, it said in my real-world scenario, it tells me the rule governing the record states that the minimum distance covered must be at least 26,700 kilometers. How far did they travel? They traveled 46,748. So, yes. The record was 26,700 kilometers. They traveled 46,748.4 kilometers. They almost doubled the record, which is incredible. Good job on that so far. Let's get into the graph. Graph the function and use your graph to approximate how long it took them to travel 20,000 kilometers. We love graphing because we are good at it. We had a lot of practice in 9th grade. We're going to get a lot of practice this year. Let's get our labels first. So X is hours, Y is kilometers. So number of hours, number of kilometers. Now, we could go through the whole set up a table and pick values for X and pick values for Y. But starting today, we're going to use our domain and range to get our ordered pairs. So if I'm going to just rewrite. My domain was 0, 478. And my range was 0, 46,748.4. Now, if you think about it, right, here was your X value. You plugged in that X value and you got this for Y. This was your largest X value and you plugged that in and got this for Y. So we can actually be strategic and use our work for domain and range to actually get the ordered pairs 0, 0, because when you plugged in 0, you got out 0, and then 478, when you plugged in 478, this is what you got out. So 46,748.4. And that's all you need. You just need 2 ordered pairs to plot a line. So no work needed. How awesome is that? We do need to decide on how we're going to count. What's our scale going to be? And this is where it's kind of more like an art. It's not a science. So make sure you're using pencil. So if we make a bad choice, we can erase it and try something else. So for my X values, I see that I'm trying to get from 0 to roughly 500. So this is going to be 0. But how do we get to 500? Let's see. If I count by 20s, 20, 40, 60, 80, 100. That's 100. 20, 40, 60, 80, 100. That's only 200. That's not far enough. So we can't count by 20s. Maybe we try counting by 50s. So 50, then this would be 100. 150, 200, 250, 300, 350, 400, 450, 500. Okay, that worked out for me. So we're going to be counting by 50s on the x-axis, and you don't have to label everything. So notice I didn't label 50. That was 50, this was 100. So you can label every other. Now for my range, I'm going from 0 to approximately 50,000. So to help us out, a good strategy, if we say that our label is number of kilometers in thousands, then we can actually say we're just trying to get to 50, because that would actually mean 50,000. So let me say that again. If we redefine the label to be number of kilometers in thousands, instead of trying to put the actual like 50,000 somewhere on here, we can just get to 50. I'm going to show you how to do both, just in case you didn't follow that. So let's pretend like I hadn't put the in thousands. So this would be if I counted by 10,000, 10,000, 20, 30, 40, I would hit 50,000 and I wouldn't have even like really used the rest of my scale. So maybe instead of counting by 10,000, I count by 5,000. So this would be 5,000. This would be 10,000, 15, 20,000, 25, 30,000, 35, 40, 45, and then 50,000. That's better. It's a little more spread out. If you want to challenge yourself to come up with something else, feel free. So each of these tick marks represents 5,000. Now, if you do this, where you say in thousands, I'm going to change the color of it. So just watch what I'm doing in red, don't write it down. But if you wrote in thousands, then you could actually just put 10, 20, 30, 40, 50, because then 50 would actually mean 50,000. So you make a choice on which way you like better, what I just did in red or what was in purple, to make a decision on what label you're going to put. I'm going to leave the notation with the actual thousand part of the number. So for me, I'm going to erase this. Just providing you some strategies. We're ready to plot our points. So 0, 0 is going to be right here, 0, 0. And then 478, let's see. This is 400, this is 450, and this is 500. So 478, I'm just going to make a little like dot for myself right there, just so I keep track of where 478 is. 478, it's not an ordered pair. I'm just putting a little dash. And then the height in kilometers, 46,748. So here's 40,000, 45, 46 is going to be like a little higher than 45. So again, I'm just put a little dash, because then if I have these little dashes, these little tick marks to help me, I know I'm going to go up, 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 and then I look for where I put my little dash on the y-axis, and there's the ordered pair I need. Notice it's really not on the grid. It's kind of in between, in between, in between, in between. So we're improving our graphing skills. Please take a straight edge of some kind, either the side of an index card, a ruler, take a piece of paper, fold it in fours, and use that edge to get a line. Now, here, I just extended it all the way past, and I was about to, out of habit, put an arrow at the end. But would this be a correct graph? Think about that for a second. Well, I know that their journey only lasted from hour 0 to hour 500. So it is not correct for me to extend that line all the way. This is actually going to be a segment from here to here. This is not a line that goes all the way through, because their journey had a fixed beginning and end. So our graph is going to be a segment. To answer this question, approximate how long it took them to travel 20,000 kilometers, we are going to go to our y-axis, because this is where 20,000 kilometers is. And I'm actually going to just trace over. I'm going to look to see where I am on my graph, and then I look down, and that was hour 200. So how long it took them? 200 hours. And all I did was use my graph to get that information. And we are done with this example. So I'm going to stop there at page 31, and we will pick up with, in class tomorrow, as a reminder, you guys comparing your answers for these two that we left blank, and keep going with a debrief and more class practice on real-world domain and range. So again, stopping tonight's video here at page 31, for flip notes. Please take a minute and do these 2 graphs to be ready for the start of class tomorrow. And I will see you tomorrow. Have a good one, guys. Bye.